Working with complex numbers and putting them in polar form can be somewhat abstract. You have to know a couple background pieces. First of all, a reminder that the absolute value of a complex number is equal to the length of z. And notice on a complex number, the real number is graphed on the x-axis and the imaginary part is on the y-axis. You can use the Pythagorean theorem to get your z when relating your a and your b. Also, note that to find the form of a polar form of complex numbers, it's z equals r times parentheses cosine theta plus I sine theta. This is the form that you're going to be using for the polar form of a complex number. That you have to know, very important as we go through. Let's take a look at a couple examples. First of all, if you're looking at what is the polar form of this, again, what I would do is graph it. So this is your imaginary part right here, 1 and -1. And again, you're looking for what is that angle. That angle is going to be 7 pi over 4 because it's 45, 45, 90. And this length right here, since it's 1 and 1, that's going to be square root of 2 by looking at that 45, 45, 90. And now you have that this is equal to, let's see, it's the z, or the r value. R is square root of 2. And then it's cosine 7 pi over 4 plus I sine 7 pi over 4. Looking at the second one, you now have a case where it's going to be 3 and 2. Again, you can find out what this value is by a Pythagorean theorem, square root of 13, and then you'd have to use tangent inverse to find out what that is. So the tangent of theta is equal to 2 over 3. So you would take the tangent inverse of 2 over 3 to get your theta. And then when you go ahead and do this, again, the right form would be your r value times the cosine of whatever angle this is, that one right there, I'll just call it theta, plus I sine theta. Again, substituting in that number in for your theta. And you can do the other way as well. So in this case, it's expressing it in rectangular form. Now, when you go ahead and graph this, all you're basically doing is looking at what is your r and what is your theta. So pi over 6 and 4, that's going to give you that point right here. And to find out what this equals, all you do is simplify. So it's going to be 4 times square root of 3 over 2 by the table or unit circle plus I 1/2. That means that this is going to be 2 square roots of 3 plus 2I. And that would be the complex, the rectangular complex form. So real important, this is just simplifying and getting your answer and then plotting by knowing what your r and your theta is. And you would just do that on the other ones as well.